I am briefing the lesson 34 population growth. The model of the law of natural growth, top left, is the expression that assumes the population grows at a rate proportional to the size of the population. The population growth rate is dp dt, and that's how fast it is going at a given time. The k is a constant, and it's the relative growth rate, and then the p is the size of the population at some time. The rate at which the population grows is proportional to the population size, so that if you increase the population size, so will dp over dt. If you double, the rate will double. We first want to derive a general equation that we can apply to different world problems to calculate the population at any time of t. So we start with the law of natural growth expression, and first we'll cancel out the fraction on the left side of the equation by multiplying both sides by dt. And then next we need to separate p from dt so that the population can be found from a specific time. And then we're going to integrate both sides. The antiderivative of 1 over p is ln p, and the antiderivative of k is k itself because it is a constant. And then the integral of dt changes to t plus the arbitrary constant of c. Now we need to get p by itself still. So on the far right, I started out with putting the equation on top of e, so e raised to ln p, and we must do it to the other side so that e raised to the kt plus c. The e's will cancel out on the left side, and it leaves us with p equals e raised to the kt plus c. Since e raised to the kt plus c is added using algebra, we know that the numbers and variables that are raised can add together. So we will change it to e raised to the kt times e raised to c. E raised to c is a constant, which just becomes c. So then we have p of t equals c times e raised to the kt. Here we're not done yet, so we need to set t to 0 to find the initial population value at 0. And p of 0 is equal to c times e raised to k times 0. C times e to the 0 makes c times 1, because when e is raised to 0 is 1. Therefore, it tells us that c equals the initial population and derives our final equation of the population at any given time, which is the initial population times e raised to the kt. So here is an example to apply the equation and understand how to solve population growth problems. This table here shows a rabbit population on an island where t is the number of years beginning with the year 2000. The first thing we need to solve is to determine the relative growth rate. The relative growth rate is the variable k in the general equation. So we can see through the table that p of 0 is 1500 rabbits because that's where t begins. And we can fill in p of t, which is p of 0, as 1500, equaling initial population times e raised to k times 0 as well, since t is 0. E to the 0 is 1 again, so initial population equals 1500. And then to find the k, we're going to plug in a value from the table and solve for k. And for simplicity, I'll do 2001, so p of 1 is 1577. 1577 equals 1500 times e raised to k times 1. K times 1 is just k, and 1577 divided by 1500 is 1.0513, and that would equal e to the k. And then to change that exponent of k to a standalone variable, we'll take the natural log on both sides. And the property of logs tells me that I can put k, the k constant, in front of ln times e. And then therefore we have 0.05 equals k. Part B asks us to use what we found to generate an equation from the population at any time for this problem. So we can use the general equation and fill in k, which we just found, which is 0.5, and that gives us our final answer. And this basically tells us that the population increases by 5% every year compoundly. Part C asks us to calculate the population in 2010. So to this, we're just going to simply use their equation of p of t equals 1500 times e to raise to the 0.05t and replace t for 10, because since 2000 is t equals 0, then 2010 will be t equals 10. The calculator tells us that the population in 2010 will be 2,437 rabbits. And then finally, part D asks us how many years it will take for the population to double. And to double the population, we have to go from 1,500 rabbits to 3,000 rabbits. And to find this, we'll reverse and replace P of t with 3,000, and then solve for t instead of solving for P of t to find the amount of years it will take. So first, we will divide both sides by 1,500, leaving us with 2 equals e to the 0.05 times t. And then to make t a variable instead of an exponent, we will take the natural log of both sides again, giving us ln times t equals 0.05 times t. We'll isolate t on one side to find how many years by doing ln times 2 divided by 0.05, and that gives us 13.86 as t. And we'll round to the nearest whole number, which is 14 years. Therefore, it'll take 14 years for the population to double, which is in 2014. And this concludes my brief on Lesson 34, Population Growth. Thank you.